from 0 to 50. So if you look at this very well, I'll still set up one there. If you look at this very well, this is 50. I told you the 50 is at the where? Bottom. Do you remember?
Yes.
And I told you the 0 is at the where? The top. And they are in centimeter cube. If you remember, I told you when you have ml, mil, it's still the same thing as centimeter cube. I hope you did not forget. If I write 50 ml, it's still the same thing as saying 50 centimeter cube. So this is what we call burette. Any question? This is what we call what? Burette. B-U-R-R-E-T-T-E. Is that clear? Okay? We also have what we call pipette. 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 Okay, define one. What do we use burette to do? Who can tell me? To what? To measure our acid, the volume of the acid. Do you understand what I'm saying? We use our burette to measure what? The volume of the acid. Then we have what we call pipette. You know I drew those the two for you yesterday.
Yes.
This is what? Burette. Now this is what we call pipette. What I call it? Pipette. And I told you that pipette is in two types. Do you remember? What's the first one? The one of 20 centimeter cube and one of 25 centimeter cube. So now, if you look at this now, you know I told you. Hello, are you listening to me? That the one of 25 or 20, they will write it there. And I told you the precautions of all these things. Hello, are you listening to me now? So let's say for example now, we are in the exam. And as a chemistry teacher, I use 25 centimeter cube for my own titration to get my titer value. That means all the students in that center must use 25. If you use 20, you are on your what? Own. Are you listening to me now? So if I'm using 25 centimeter cube, and you now see 20 centimeter cube on your own table, it's better you talk. Are you listening to me now? Okay, you signify that the pipette on your table is what? 20. Do you understand me now? So we must all use the same pipette. Do you understand me now? As what? 25 centimeter cube. So you can all see it there. 25 ml. Or do you see centimeter cube there? No. But I told you, it's still the same thing as saying 25 centimeter cube. So this is what we call the what? The pipette. And this is what we call the burette. Any question? I also told you we use what we call the spatula. Okay, we can use this one to take all these what's it called? Grain, like powder, like what we want to mix together, anything that is powdery that you cannot use your hand to take them. So you use this. This is what we call the spatula. It's like a spoon. We call it what? Spatula. And I also told you now, we have two types of reagent bottle. We have the black and we have the white. So this black mainly, we have the black and we have the white. So this black is used to store acid. It's used to store what? Acid. You know, acid reacts with light. So, but with this black, light cannot penetrate. Are you listening to me now? So we use it to store the what? Acid. And here we have the white. We use this to store the base. Do you understand me now? Okay. So I told you also, we must use a volumetric flask. Is there? I gave you the apparatus. A what? Volumetric flask. We have the one of 250, we have the one of 500, we have the one of 1000, and we have the one of 2000. So you can see this is 2000. It's written there. Also write it there. Okay, but this is the one of what? 2000 mil. That is 2000 centimeter cube. And we have the one of 500. Can you see it now? We wrote this one. This one is what? 500 mil. That is 500 centimeter cube. We also have the one of 1000. The same shape. Do you understand me now? And also we have what we call the conical flask. The what? The conical flask. The conical flask. And we have what we call the beaker. You have the beakers different size. This one is 250 mil. That is 250 centimeter cube. And if you look at this one is 600 mil. That is 600 centimeter cube. And we also have what we call the funnel. The what? The funnel. You all know funnel now? Or you don't know funnel? This is what we call the funnel. And we have what we call the retort stand. This is a what? A retort stand. A retort stand. And in the retort stand, okay, we have what we call the clamp. The what? The clamp. C-L-A-M-P. This is the retort stand. This is the what? The clamp. So now, let's now go to the question. So I will teach you how to set up, and we'll carry out the experiment together at first, and the second time you carry it out on your own. So please listen very well. If you go to the question, A is a solution. You have written the question, right? A is a solution of potassium tetraoxomanganate 7. Have you written the question, please? So turn your notes to the question. A is a solution of what? Potassium tetraoxomanganate 7. Another name. Sorry, I want to get marker. So can we proceed now? A is a solution. Now, look at it. If I want to do it, if it is exam period now, listen to me now. I will only pour A inside the reagent bottle. Are you listening to me, please? And I will just label it as A. Hello? I what? Label it as A. You as the candidate, are you listening to me now? According to your questions, you know what A is. You understand what I'm saying now? But I will put what is supposed to be here, and I will label it what? A. So if I label it A, you go to your question, what is A? That means what is inside here, which is A. I'm only using this as an example now. What is inside here, which is what? A is what? Potassium tetraoxomanganate 7. Another name. Who can tell me another name for that? Another name for potassium tetraoxomanganate 7. Another name. I didn't ask for the chemical formula. Another impact name. That's another name now. It is known as potassium permanganate. Potassium permanganate. I'll write for you now. Potassium, write potassium, then ER, then manganate. Potassium permanganate. Okay? Potassium permanganate. Please be careful, don't let that glass break. Oxomanganate 7. It's still the same thing as saying potassium permanganate. Okay, the two is the same. Potassium, okay, tetraoxo. You know that's the next thing. But I told you that this manganate will be the one that will be at the middle. Do you remember that? So that is manganate is Mn. Then tetraoxo is what? Tetra means what? 4. 4 of how many? Oxygen. Do you understand me now? 4 of what? Oxygen. So that will be O4. Then if you want to confirm if this answer is correct, you calculate the oxidation number for manganese. Hello? You calculate what? The oxidation number for manganese. And if you want to calculate the oxidation number, it must give you 7. I told you yesterday now. Abi? So let's calculate that now. What's the oxidation number for potassium? Who can tell us? Oxidation number for potassium. Oxidation number for potassium. I expect them to be telling you that. Oxidation number. That's atomic number. So with the atomic number, you get oxidation number. I explained to you. Oh, you are not in the class. Sorry.